Okay, this is going to be so much fun. I love this talk. Here are my slides. It will be live demos only. This is so cool. We're going to talk about all of the pieces inside the .git folder. We're going to look at objects, refs, logs, hooks, configuration, and temp files. And so we'll kind of dig in to all the things at each of those places. I would point you to my slides, but there aren't any. But you can definitely reach me by tweeting at RobRich or by visiting the contact page on robrich.org. So, put your questions here in slides. But if you have other questions that you learn tomorrow or next week, then definitely post them there. A little bit about me. If you come to robrich.org and click on About, I'm a Microsoft MVP, a friend of Redgate. AZ GiveCamp is wonderful. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software to the charities. It is really, really fun. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like an AZ GiveCamp in your area, then hit me up on Twitter or by email, and let's get philanthropy installed in your community as well. I do Git training with gitgrit.com and also Docker and Kubernetes, .NET and Node. So if you'd like to have this happen in your organization, I definitely can help you with that. I run the Southeast Valley .NET user group here in Phoenix, Arizona. But my real claim to fame is that I posted a comment on a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So that's my claim to fame. So let's look at Git. I have here an empty folder, and I have an empty folder. And so here in that empty folder, I'm going to say Git init. Now Git init will create this as a Git repository. So now I can run Git commands inside that Git repository. Now this Git repository, this .git folder, is the entirety of that Git database. Now I went into View, Options, and I chose to show hidden files and folders so that I can see it by default. But you can see that it's kind of dimmed. If you don't see it, go turn on View, Show Hidden Files and Folders, and you'll be able to see this. This is that Git database. And we're going to talk about refs, objects, logs, hooks, configuration, and temp files. So we'll go through all of the pieces of this folder. So first off, let's create some commits. Echo file1 into file1.txt, git add file1, git commit -m file1. I'm going to break convention and not call this initial commit. But you can see some stuff happened. Let's first look at objects. Now we have in here 3 objects inside of our Git repository. 7a, 9.4, b9. Well, actually, there are 3 folders. The info and pack directories we'll talk about in a bit. If I were to open this up, this .git folder in VS Code, I can see that we have these objects, 7a, 7b, f, blah, 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 and we can go look at each of these objects. Here, I'll say git log, and we'll see that 7a, 7b, f93 is one of the commits. What that is 7a, the first 2 characters of the commit hash is the folder name, and the balance of it is the file name. Now, if I pop open this file, it'll tell me, oh, look, this is a bunch of garbage. Well, it's not a bunch of garbage. It's a zlib encoded file. So, zlib, zipped. Zlib is actually more closely related to deflate than other zipping compressions, but that's the mechanism. Each of these is a zlib compressed file. And so if I were to change content in here, I would definitely break Git. But just looking at them, yeah, it's not encoding correctly, but I can see the content. So let's go look at this. Now, there's various tools we can use to look at the contents of these. this, oh, this is talking about how to deflate it. There's, oh, where is it? OpenSSL zlib is one way to decompress these, which is really cool. You can also just pull in interesting things. So let's actually do that. OpenSSL zlib .git /objects/94/ Okay, so that's the contents of this file. The first stop, it says it's blob. It's a node of type blob. It's 9 bytes big, and it has these bytes in there. Or this is the commit message, rather. Looking at this closer, I created this command line tool that allows me to look at these things as well. Here is unzipper, and unzipper is just a node app that uses zlib to decompress them. And so if I put unzipper in my path, now I can say unzipper.git objects 9448. Now I am splitting by nulls here, so we see that there was a null between here, and then we have 9 bytes. 1, 2, 3, 4, 5, 6, 7. The carriage return, or the carriage return, and then a null. There's the 9 bytes. But actually, this 9.4 isn't the one that we see in this commit message. This is 7a. So let's go look at that one. Unzipper.git /object/7a/. Okay, so this is an object of type commit. That was an object of type blob. This commit then has 178 bytes in its commit message. And here's all the particulars. Here's my commit message, the one that said file 1, but we also have some other references. Author and committer, it was me. Here's my email address. Here's the date and time zone that I made this commit, that I authored this commit and was the committer of this commit. And it references a tree node, B97F. Well, let's go look at that one, unzipper.git objects B9. This is a tree node, and a tree node, it is of size 37 bytes. A tree node references the file permissions, read, write, execute, the file name, and it also includes a binary encoded Git hash of that blob. Now, it's difficult to read this straight out of the way, so we can also use git cat file -p B9 F7, and it will actually decode that Git hash on the way through. So we saw that interesting tree. The commit references the tree node references the blob, and if we git cat file -p that blob, oops, not that blob, that blob, then we'll see the actual file contents. So the file contents are stored differently than the file name and permissions. And that's really helpful. We'll come back to see why that's really helpful as we get going. So let's add some more stuff. Echo file2 to file2.txt. And we'll come back into this objects folder. Git add file2. Now, when we add file2, we see that there's a new node in here that we haven't seen before, this 2.6 node. Git cat file -p 2.6. Oh, 2.6 isn't a long enough thing. Git cat file 2.6. Okay, so here's the contents of this thing. As I added it to the staging area, it actually committed that blob into my object folder. It did that straight away so that it could track it. That's how when I'm changing a file and I've committed part of the file, it already committed that, that node, the blob node, into my repository. Git commit -m file2. And now as I commit it, now I get two more nodes. I get the commit node and I get the tree node. Git log, I can see that that commit node is C0. Git cat file -p. Let's look at that. It is a commit node, and here's the content. It references this tree node. Git cat file -p. There's that tree node, which now references two files, file 1 and file 2. Here's that new file 2, git cat file -p. And there's that file 2. So that's one interesting thing to note, is that as I'm adding things to my staging area, I'm creating those blob nodes straight away. Well, let's do something else. Git mkdir folder echo file1 into folder /file1.txt. Now I've very carefully crafted file1 to be identical to what we did before. Git add file, git add folder /file1.txt, git commit -m folder file1, git log. Okay, so now in this commit d3b0, let's take a look at what that did. Git cat file -t. I'll do -t to check out the type of this node. It is a commit node. That's pretty cool. Git cat file -s. How big is that node? It's 233 bytes. Git cat file -p. Let's go look at those 233 bytes. And it references a tree node that is here. Here's my parent node. Here's the committer information and my commit message. So looking at this tree node, git cat file -p, I noticed that this tree node references this other tree node. And it just says, hey, that other tree node is the contents of this folder. Git cat file -p. Here's the contents of that folder. It is this blob that is 94468. Well, we've seen 94468 before. Here's 94468. Because the file is identical in both places, Git doesn't need to store the blob twice. Rather, it just references this straight away. So we've got this cat file. Let's do some other interesting things. Echo file5, file5.txt. Git add file5. Now that's going to create the blob node. Now if I come in here and modify file5, modified, I don't need the quotes, but just for the sake of experience. Now I say git status, it's going to tell me that I have some unstaged changes in file5 and I have some modified file5. Git add file5, git status. Now I have that staged file5. Git commit -m file5. Now in theory, I have the blob that was just the original thing, and I have the blob that is the changed thing. It'd be kind of nice if I could, go poke at those more directly. When I say git log, I now have this commit node, git cat file -p, and that references this tree. And that references this file5. And this file5 is the modified file5. So where's the blob for the unmodified version? Well, it's still there. I still have content here in my repository. Let's do another one. Git echo file6, file6.txt. git add file 6, git commit -m file 6. Now I want to amend this commit. I forgot about something. I want to say add content here. Now I could do squashing and interesting things, but let's do this instead. Git add file 6, git commit -amend -m file 6 modified. Did I mean 2 dashes? Yes, I did. Okay, git log. Now I see here, this is file 6 modified. I have this commit. So what happened to the previous commit? Well, it's still in there. It's still doing the stuff. Well, what if we had an interesting way to browse through all of these things? So I built this tool. Where is it? There. If you go to github.com/robrich/git-explorer is this project that allows me to kind of view all of the DAG nodes in my Git repository, not just the commit nodes. So let's fire that up. npm run start. Listening on port 3000, that is awesome. As part of this repository, there is this Git repo configuration file, and I've just pointed it to the path for this repository that we're looking at, so I can take a look at it. So here's each of my nodes, and this probably doesn't make a whole lot of sense. They're just each of the nodes here in the folder is represented by a dot in the graph. So let's show some content associated with this. Okay, so 0C, 2B, 3F, 6B, and we can take a look at each one and look at the content. Well, this is a tree node. Here's the parents. Well, that's interesting. It just browsing through the commits, and that's fun. But what if we put them in a parent-child relationship instead? Now I'm going to show the types so I can tell which ones are commits, which ones are tree nodes, which ones are blobs. Here's this commit, or here's this commit, and this is the unmodified file 6. It references this tree node that references the unmodified file 6. Here's the unmodified file 6. Those 3 nodes still exist in my Git repository. But then I amended it to make this node, and this node is a tree node with a file 6-modified comment, and it references this new modified file. Well, the interesting thing in this commit node is we see that the committer timestamp is different than the author timestamp. When I modified it, I modified one of those dates, but not the other. And that's why we have 2. One for the time that we did it initially, one for the time when we amended it. And that's pretty cool. So this, let's show some tags. Let's try that again. Let's show the types. We'll put it in parent-child. We'll put on lines. We'll show the tags. And now I can quickly browse through all of the content in my repository. As I click on each one, it will show me the content here in the other pane, showing me not only the type of node, the full hash, but also the file or the tree node contents or the commit contents. So that's objects. Any questions so far?
No questions, Rob.
No questions so far?
At least
okay, so
I have one question from Matt. He wants to know how you are showing this graph.
Ooh, how am I showing this graph? So in this application, I actually go list out all of these nodes and pop open each one with that unzipping tool. And given each one of those, I can say, okay, so here are the child nodes associated with that. In the commit node, I go grab the parent node. And then this visualization is using D3 to go put all of those in order. So the code is a little messy, but it's actually pretty cool so far. Just being able to see them in alphabetical order or in parent-child order. I think it's pretty sweet so far. And again, that code is available on github.com/robrich/git-explorer if you want to fork it or use it or help me make it better. I'd love to have your help there. So we dug really deep into the objects folder. We saw how we have commit nodes, we have tree nodes, we have blob nodes. We saw that over time, these there can be a whole lot of nodes. And that's kind of interesting. In time, we might have too many files here and we want to pack them together. So let's do this. I'm going to, actually, let's go to refs and we'll come back to packing. So objects, refs. Now here inside the refs folder, we have interesting files like heads master. Okay, so ref heads master points to E4507. E4507 is right here, E4507. So that's just a text file noting which node this ref points to. Here's head at the root of the project, and it just says, I point to refs heads master. Head points to master, master points to somewhere else. That's pretty cool. So let's use that. Git log -- one line -- decorate gives me my branch labels. And now I can see that head points to master and master points to E4507. Git checkout. Let's check out here. Now it's telling me I'm in a detached head state. The unfortunate part is this is one of the more scary messages that you'll see in Git. It's like, okay, so I took my head off. Am I in a zombie place? Well, what it says in a detached head state, if I open up this head, head doesn't point at a branch, head points at a commit. That's all it says. Head points at a commit. Okay, so let's create a branch. Git checkout -b new branch. Git log -- one line -- decorate, and I'll say -- all so that I show all the things. Head points to new branch points to this commit. That's pretty cool. If we pop open the refs folder, now we see this new branch that points at this commit, and we see that head points at that new branch. Well, let's add some commits in here. Echo file3 to file3.txt, git add file3, git commit -m file3, git log -- one line -- graph -- decorate -- all. And graph will do this cool ASCII art kind of thing. So now I see new branch goes this way and master goes that way. Git updating my visualization here. Let's see exactly that. Parent child, lines, tags, let's show types. Here's new branch right here pointing to this commit node. This commit node points to this leaf node. This leaf node points to this file. Hey, what's up with this file, file 5? Oh yeah, remember when we did this thing, we pointed at this and we never actually committed file 5? File 5 is, oh, file 5, that's interesting. Oh, this is the unmodified file 5 that nothing points to anymore. Here's that modified file 5. That's pretty cool. So refs. Outside this Git folder, I have this new folder called server. And let's pretend this is our Git server. Right now, it's an empty folder. Git init, and I'm going to say -bear. And by saying --bare, I'm saying only put the contents of the Git folder here. Don't create a .git folder itself. This is perfect for servers where we don't need a checkout directory. We don't need a head. It still has a head, but here's that server. So if we go back into our regular folder, git remote add origin, and origin isn't anything special. I could have named it anything, but let's call it origin. And what's the URL to my origin? I could say HTTP GitHub or GitLab, or I could say / server name / share. In this case, I'm going to say the path to my server is / server. Git push origin master. So now here in my Git folder inside refs, we now have a new folder called remotes. Let's go look at that remotes folder. So inside that remotes folder, we have an origin folder, one for each remote that we have. And inside origin folder, we have master. Here's where I told the server it was last. Or here's where I believe that the server is at E4507. Git push origin new branch. And now not only do I have a origin, not only do I have a master label there, I also have a new branch label. That's cool. Let's say echo file 4. Do I have a file 4? I do not. Echo file 4 into file 4.txt, git commit -m file 4. Oh, git add file 4, git commit -m file 4. Git log -- one line -- graph -- decorate -- all. We see that our new branch now is different from where the origin's new branch was. Our master and our origin master align. And so we can get a feel for where all of those are. We have in here our master, our new branch, which points at BFF06. We have remotes, new branch points at B55B. That's, backed up one right here. And so we can get a feel for how all of those branches and tags work. The only thing magic about these tags is they just happen to be in a folder called origin. Git tag 1.0 master. So I'm going to create a new tag on master. And here's that tag. Now the tag points at a commit. I can see that by opening up the tags folder, and here's that 1.0, and it points at that commit. Git push origin -- tags. I'll push that tag to the server. Now I would expect to now have remotes tags, but it actually doesn't. It just only shows the branches, probably because the presence of a tag is sufficient, and I don't expect those tags to move. Okay, so we talked about tags, or we talked about refs. If I come back to this visualization tool, if I choose to show lines, show type, tags, we'll highlight the branch here. Now I've trimmed off the refs heads part, so I can't tell which one is the local master and which one is the remote. But if I click in, it'll tell me here's refs heads master and here's refs remotes origin master, so that I can get it. Here's also refs tags 1.0. So I have that 1.0 tag on this commit as well. So we talked about pack files. Let's come back to pack files. Here on my server, I have a bunch of objects, and in time, those might get expensive. Now Git will run this behind the scenes whenever it needs to. Git GC, garbage collect, and Git GC will go take all of these commits and pack them into this small pack file. Now I have one file that is a pack file, I have an index file, and I have a bitmap file. Not sure what the bitmap file is for. The index just keeps track of what's in the pack file. But you notice that I also packed all of my references into place too. So these are empty. All of those references are packed into this pack file as well. So I can unpack these if I want. Let's rename this to unpack, just so that we'll, quote unquote, get it out of the repository because it won't duplicate them. And now let's git unpack objects, and we'll point it to /git/objects. Oh, it's not in a Git folder. Objects/unpack, and we will go after that pack file. Now, when I unpack the objects, again, it will double check to make sure that these objects don't already exist, but then it will unpack each of them into place. So now we see all of the pieces. Now I've unpacked the objects. I haven't unpacked the references though. Those are still in this pack file, but yeah, the server still works correctly. But that's that pack file. It's a zlib compressed copy of all of those nodes that Git will unpack as whenever it needs to, or just leave packed to save space. How are we doing through our Git folder? So we've talked about objects. We've talked about refs. We've looked at how refs point to objects and how objects can get packed into interesting things. Well, what happens if I were to lose a branch? Git log -- one line -- graph -- decorate -- all. So I'm going to say git checkout master, and I'm going to say git branch -d new branch. Now, why did I delete the branch? I don't know, but here we are. Git log -- one line -- graph -- wait a minute, where'd that commit go? Well, if I refresh my visualizer here, parent child, let's show these, we see that that commit is still there. There's just no branches pointed at it anymore. Well, how do I know it's there? How do I get back to it? And that's where logs come in really handy. Right now, here in the logs folder, we have a refs folder that talks about where master has been at any particular point. So it will say, I was here and I moved to there. I was here, I was here. And so it's that running log of where master was. We have a running log of where all the remotes are. And we have a running log of where head has been. And this can be really, really helpful because I can use this ref log to get back to where I expected to be. So let's use this log. Git ref log. Now by default, ref log will look at head. And so it says, okay, so I was here and then I was here and then I was here and then I was here. I used to be right here on BFF 0628 and then I moved to this E45. Well, let's go back to this BFF git checkout there, git checkout -b new branch. Git log -- one line -- graph -- decorate -- all, and I've got my branch back. Ref log can be really helpful in knowing where I was and helping me get back to things. Now, periodically, Git will run that git gc behind the scenes, and so whenever git gc runs, it will go prune nodes that aren't attached to anything, like that unmodified file 6. And it will prune these commit nodes that aren't pointed to by any branches or aren't parents of any branches. And that's why when it said git checkout a commit, I'm in this detached head state, and it really warned me about that. And it said, don't look around, don't get to a real branch, is because when it runs that git gc behind the scenes, it may clean up that content. So at that point, reflog may tell me it's there, but it's not there. Git log dash dash one line dash dash graph dash dash decorate dash dash all. So how do I back up my content? Git push origin new branch. Once I've pushed this content to my remote, now I know that my remote has this node as well. Git checkout new branch. Odd that it said my head was down here still. That was kind of cool. Okay, so now I've got my content. I'm no longer in a detached head state, and we've kind of looked through logs. That's cool. The logs folder will allow me to get back to interesting things. So next, let's look at the hooks folder. Inside the hooks folder are a bunch of things that look like bash shell scripts. Here's a commit message .sample, and it says, to enable this hook, rename this file to commit message, removing the .sample. They don't necessarily need to be shell scripts. Here's a Perl script that does some interesting things. So if I want to enable these hooks, I just rename it to this thing. Now each one will accomplish a task at a particular stage in my process. So I have this folder here of hooks where I just did that. I renamed each one into place. Copy. Actually, let me grab the files. Copy, paste. Now in each one, I just said echo the name of the hook, and I'm echoing all of the command line arguments passed to it. So we can get a feel for how each one is going to work. Here in this commit message hook, I'll echo all of the things passed to commit message. Okay, so echo file 7 to file 7.txt, git add file 7. Okay, so there's no hook for adding a file to the staging directory. Git commit -m file 7. As I committed it, there was the pre-commit hook, the prepare commit message hook, where it's talking about this commit_message file. Then I have the commit message hook after I've made that commit message. It found it on the command line, so it didn't need to prompt me. And ultimately, it did all of that content. Git push origin new branch. I got some more, the pre-push hook. Well, when would I use these hooks? Why is this helpful? Well, if I want to do certain things at certain stages, I can hook into this. Perhaps on the way into committing, I want to run my linting tool to make sure that all of my files are linted correctly. And maybe before I push, I want to run my unit tests to validate that my system functions correctly. Don't let me push if my unit tests fail. And so that could be a really elegant hook here. So there's a package called Git Hooks that allows an NPM package that allows me to hook into this, where they go create these files for me to do really interesting things, to run node commands when I do interesting things. Now, part of the bummer here is that this hooks folder is inside my .git directory. And so as I push my content into place, these files aren't part of that. Git status, we see that there's nothing there. I can't git add .git /hooks/ that's not a thing. Git status. Nope, it's not a thing. So as I push here on my server, you'll notice that that hooks folder is still the samples. These are specific hooks to my system, not to our project as a whole. So how are they useful at all? What's really cool about this Git Hooks package is as it installs it, it copies files into place that are just small shims into a folder inside my project. So then this folder inside my project will get versioned with my project. So now because my scripts are out here, everything is fine. Git Hooks is a great way to start to automate some of the difficult tasks that I would usually forget, Let me do a hook to run linting. Let me do a hook to ensure my build compiles and my tests pass. And at that point, then those pieces that I might otherwise forget can get done for me automatically as I do the tasks that I need to do. Perhaps I don't accept branch names that have mixed case, or perhaps I don't accept commit messages unless they follow this format. All of those pieces can be built into Git hooks to allow me to be more productive and let the machinery do those kinds of heavy lifting for me. So our next step is configuration files. As we're looking through this .git folder, we see this config file. Now this config file lists all of the details associated with my repository, but this one overrides and is identical to the one that I have in my profile. So if I go into my profile and I look for my .git config file, my .git config file, has a bunch more details. As I first set up Git, I entered my name and my email, and I may have a GitHub username, my merge and diff tools. If I want to make specific details for this project, I can put them here in this project's config file. Perhaps this is a business project. So instead of being robrich at robrich.org, it's robrich at richardsonandsons.com. And so now I have a email specific to this project that is different than the one assigned to my user. There's a third level of configuration that is installed with Git, and it's in the install directory. So in my case, I'm on Windows. It'll be in program files /git / baked in there, there's a config file. I don't recommend you edit that, because anytime you do, and then you reinstall Git for a new version, then bad things happen. So anything that is global to all projects, I'll put in the .git config in my user profile. And then anything I want to edit specific to a particular application, then I'll put in its git config, the config file inside the .git folder. So that's one piece of configuration. Here's another piece of configuration. Inside the info directory is this exclude. Now I could choose to exclude bin, obj, .vs, node, modules, packages. I could put this here, but this is a really bad idea. This file is inside the .git folder, which means git status, it is not committed to my repository. There's a different way to do this. If I say, if I create a .git ignore file in the root of my project out here, now I can do this content in my .git ignore file, and now I can version that ignore file. So I would propose that this this exclude file should be deprecated. It's not, because I may want my user-specific excludes that are different than the project's excludes. But in the majority of cases, I would argue that a .git ignore file is a better use for this. But there's that exclude file. Other configuration files, here's a description file. This description file is used for Git InstaWeb. You can say Git InstaWeb and it will pull up a website and do interesting things. If I had light HTTP on my system, but I don't, typically we'll probably use GitHub or GitLab or another server technology to be able to view our Git repository. So probably you'll never use description. I've never used the description file. Other configuration files in here is the index file. This is pretty cool. Here's that index file. Now, if I pop open this index file, it looks like a mess. This index file is just a mass of goo. Oh, hey, there's file names. That looks interesting. A tree node. There is a project called, the format for this file is really obscure. It's a binary thing. There is a project that allows you to read it. It's called gin. And so if you look at this repository, github.com/sbp/gin, it's a Python app that is able to read this index file. Or we can do this, git ls files. Git ls files will read that index file and show us all the content. So a smidge of magic, but it's actually really, really helpful. If I say git ls files -- stage, it will show me the full contents of that index file. So here's the file permissions of each file. Here's the hash of the blob of that file. So let's go look at this file, git cat file -p. And here's the blob. So why would it need this index file? Well, this index file represents all of the files in my working directory. If I want to do something quickly with all of these files, then using this index allows me to not need to dereference my current commit and then the tree node and each nested tree node to get to each blob node. I can just dig into them straight away. This 0 represents a merge status. So right now these aren't in conflict. If I'm merging, then mine will be 1, yours will be 2, and our base will be 3 or something like that. It's a scale of 1 to 3. But because none of them are in conflict right now, then they're all 0. So git log --1 line --graph --decorate --all will get us to our current thing. We're on new branch, git checkout master, git ls files -- stage. And we'll see now these are the files on the master branch. We didn't have the folder before. Git checkout new branch, git ls files -- stage. Here's the files associated with this branch. It's a way for Git to be able to quickly peruse its folder. Temp files. Temp files are interesting because Git has quite a few of them that just kind of wander and linger around. Commit edit message. Here's the last message that I typed. Okay. There's other temp files like commit message. Orig head sometimes will appear here. Inside the info folder, sometimes there's a refs file. And these types of small pieces are interesting in kind of keeping track of what I did last. And they're the state files that pass between things, usually between hooks. So for example, in this commit message, we see that it's going to pass in the commit message file. We saw that as .commit / commit _ message. Or commit _ edit message. It passed into this script so that we could do interesting things with it. Why wouldn't it just pass the content? Why would it pass as a file? Because Linus. But there's some temp files in here that do some interesting things. So when we look at this Git folder, we have our objects that store our actual content. We have our refs that store pointers to those things, more human readable names. We have our logs like ref log that allow us to get back to commits. We have our info that gives us exclude files. We have hooks that allow us to do really interesting things at certain points in our place. Our config files and our index, and then some temp files. None of these files are magic, but now that you kind of understand how each of them play together, perhaps Git is less magical. What is the difference between a staged file and a committed file? Well, when I look at my objects, echo staged to staged.txt, git add staged. What's the difference between a staged file and a committed file? Let's come back to our visualization here. A staged file is this file that just happens to be staged, but there's no commits pointing to it. A commit node here references a point in time when I did a thing, and it references the files that are part of that. What's the difference between a branch and a remote? Nothing. Here's this where I point to where you have the content, and here's where I point to where I have the content. There's no difference between these branches. From a usability standpoint, if I push that content to your remote, then I know that I've backed up that content. And so from a user perspective, that's really, really helpful. So those are all the points of Git and all of the interesting things that we can do inside this. Here's a page that talks about, what are each of the files and goes into similar details about, what is commit_message and what is the config file. And unfortunately, their certificate expired. So this page is not secure, but this is a great URL for digging into all of the particulars of the things that we talked about. What are your questions associated with Git?
So, hi Rob, this talk is really very insightful about Git. So I had some questions which I wanted to know. You showed about the hooks folder. So using the hooks, is it possible for someone to automate their code coverage or some code analysis tools? Can we do that?
Yes. Yes, most definitely. So how would I automate things inside the hooks folder? Now I'd have to pick where I want to send it. So perhaps this is in a pre-commit message. Here in this pre-commit message, I want to say node run my thing.js. Or perhaps I want to run .NET test. And as part of .NET test, it will go do all the things that it needs to be able to validate this. Now, .NET test is going to return a 1 or a 0, depending on whether it fails or succeeds. And I can just return that back to my calling code to say return $0 to return that back to the script. Now, if this script returns non-zero, then it will, actually, that's not how to do it in Bash. It's this. In Bash, it will, no, this is exit. It will return that status code back to the calling program. I'll know that this pre-commit hook failed and I won't commit. So whatever commands that I want to run inside here, I can do some really interesting things. I could say .NET test. I could say .NET coverage. I could say run my exe. And whatever content that does, it can do the thing. And if that succeeds or fails, then that will return that content back to the calling program. Each of these samples actually do some really interesting things. Like, let me go diff this against an empty tree object to say you can't commit nothing. There's some really, really fun things you can do with hooks.
Yep.
That was a great question. Thank you.
Thanks, Rob.
What's our next question?
So do you have any other questions for Rob?
Rob, that was really fantastic. Thank you.
Yeah, cool.
Sure. Glad to do it.
Yeah, thank you, Rob. Thank you for giving us an overview about Git folders. I don't think I have seen a talk like this covering the entire internals of what happens inside the .git folder, which as a developer, we do not open that folder at all. We just depend on the tools to do our work, but this is really informational talk.
I'm so glad.
Yeah, thank you.
As you find questions in the coming days or weeks, then hit me up on Twitter at rob_rich or reach out to me by email. Click the contact button on robrich.org, and I'll definitely dig in deep with you into Git.
Yeah, cool. So with that said, we have reached the end of our first version 1.0 of .NET open source days, and I want to thank all the speakers for your time, and it is because of you events or virtual conference always will happen. Thank you for coming and sharing your insights with us. And I also want to thank out all the attendees who have attended today, and also people who are watching us on Twitch. Thank you all. If you have any feedback, always feel free to share us on Twitter. So far, we don't have an official email address. The only thing we have is now the Twitter profile. So go there, share us your feedback. You can DM us. And I also wanted to announce that we'll be back in November with version 2.0. So I hope we bring in some other great content as well when we meet in November. Thank you all for joining today, and all please stay safe, and thank you.
Thank you again, Bhaskar.
Yeah,
Thanks.
thank you very much.
Well done. Thanks, guys.
Thank you.
Yeah, this was great. Thanks for hosting.
Thanks, Rob.